Okay, so we are going to extend probability. Now that we have a foundation of probability, this week what we're going to start doing is start taking a look at what we call probability distributions. So a probability distribution, this is a discrete probability distribution. It's this table right here. It might look a little differently when it comes time to do the notes, but this is just a basic one to take a look at. So it says a child psychologist is interested in the number of times a newborn baby's crying wakes its mother after midnight. So it's a random sample of 50 mothers. The following information was obtained. X is the number of times per week a newborn baby's crying wakes its mother after midnight. For this example, it's either 0 times, 1 time, 3 times, 2 times, 3 times, 4 times, 5 times. So the most any mother was woken up during a week was 5 times. There was a case where it was 0 times. So we want to list the requirements of a probability distribution. So the first thing we need to know is the number on the left. This is the number of times that occurred. So this was the number of times so 2 times out of 50 the mother wasn't woken up within that week. So again, these correspond to how many times the mother was woken up during the week, and then the number on the right is the probability, or how many times that was observed. So the requirements of the probability distribution are that the P of X column must add to one or 100%. And take a look at this. So these should be all of the possible outcomes right here. So if I add those up, it should equal to 100%, or if it's in fraction form, it's going to be 1. And we can take a look and check this. 2 plus 11 is 13. 13 plus 23 is 36. 36 plus 9, so 36 plus 9 is 45 plus 4 plus 1. We see that when we add the numbers on top of the fraction, we get 50. So when you add all these up, you're going to get 50 over 50, which is equal to 1. So for this to be a valid probability distribution, these all need to add up to the right side, or the P of X column must add to 1 or 100%. If it doesn't, then you know it's not a probability distribution. Now I want to make a comment about this. We might want to add or very close to 100%. Because think about it, if it doesn't add up exactly, you might, if we were writing decimals and you round something like 0.516 up to 0.52, then there might be some rounding issues. So it might add to like 0.99 or 1.01, but it's got to add to something really, really close. And then all P of X values must be between 0 and 1. Okay, so when you take a look, these are supposed to be probabilities, and this goes back to what we knew in chapter 4, and that is that a probability must be between 0 and 1, right? So all of these numbers, when you think about it, if you think about a number line, all of these numbers right here, they need to fall inside this range. And if you check those, I think they will. Okay, so it says find the probability that a mother is not woken after midnight during that week. So that is going to be they weren't woken up at all, right? That's this column right here. So the probability that a mother was not woken up, that's woken up 0 times, is equal to 2 out of 50. So this is a kind of nice way to verify probabilities, and you have them kind of nicely laid out for you. I think finding probabilities when they're set up in the table is even a little bit easier than having to do it by hand the long way. All right, so it says, how do we find the mean and standard deviation of the distribution? List the mean and standard deviation below. Let's go ahead, and I'd like you to go ahead, and if you're watching this video, let's open up the Excel spreadsheet. So once we get that spreadsheet open, the first tab we worked with was the one variable statistics tab. This one, since this is the discrete probability distribution, we're going to be working in this discrete tab. So what we're going to want to do here is clear out whatever's in here. This is where we are going to take, you see how we have This probability distribution right here, that in our problem, and then we're going to bring that in here. So on the left side we have 0, 1, 2, 3, 4, 5. And then for the right side it's going to be 2 divided by 50. It'll turn it into a decimal. 11 divided by 50. 23 divided by 50. 9 over 50. I just used the slash for the divided by. 4 over 50. And finally 1 over 50. So how do we find the mean and standard deviations? Well, those are provided to us right here. We don't, if we needed the variance, it's here for us, but we have a mean of 2.1 and a standard deviation of 1.02. So when we come over to our notes, it says, how do we find the mean and standard deviation of the situation? We use the discrete Excel tab. And it says list the mean and standard deviation below. So the mean is 2.1. So we're going to use the fancy symbols here. So the mean is 2.1, and then sigma for standard deviation is, I said 1.02. Correct? Yep, that's what we got for that one. Again, I'll tell you what to round to when it comes time to do these. All right, the next thing we're going to start to take a look at is a probability distribution. So that is spelled wrong, distribution, there we go. What are the requirements for a probability distribution? Here they are right here, and then we'll talk about examples in a second. There are fixed number of trials. There is the same outcome every time. Fixed number of trials, I'm sorry, back it up. The second is that it is independent. The next is that it has 2 outcomes. And then finally, you need the same probability each time. All right, so easy way to remember this, because you got to know these. F-I-T-S, fits. I know it's dumb, but I like to go through these and I write what they are, okay? So let's take a look at the following probability. It says a coin is flipped 32 times and the number of tails is recorded. Show how this fits the requirements for a binomial. Well, let's go through fits. Is it a fixed number of trials? And the answer is yes, because how many? There were 32 trials, right? The next one is independent. And we're flipping a coin, right? So we know that if we're just flipping a coin, the result of the first coin flip doesn't affect the second one, so it is independent. Are there 2 outcomes? And the answer is yes. It's either a tails or it's not a tails, right? And then finally, same probability. And the answer is yes, it's 1 out of 2, right? So now it says list the steps to calculate the probability of getting exactly 12 tails. Ooh, I want to clarify something here. This is a special kind of probability. This is a binomial probability distribution. So these are the requirements for a binomial probability distribution. Not just any one, it's a binomial. Again, binomial, you think about bi is 2, right? So that's why we have that aspect of 2 outcomes here, because it's either success or failure. So that's why we call it a binomial trial or probability. So, and we're going to take a look at our Excel spreadsheet. And then you see you have this tab right here for binomial. And it asks for P, N, and X. And let's try to pick out what those things are here. So P is going to be the probability of success. What are we trying to do here? We're trying to get a tails, right? So what's the probability that you flip a coin and get a tails? It's 1 out of 2 or 0.5, right? N corresponds to the number of trials. How many trials do we have? 32. And then finally, X equals the number of successes. And how many successes we want? It says find the probability of getting exactly 12 tails. So we're going to use 12 here. Now, let's get the probability of getting exactly 12 tails. So I go to my Excel spreadsheet. The probability of getting a tails is 0.5. The number of trials was 32, and I wanted 12. Let me double check to make sure that's right. 32 and 12. Yep. And now when I hit enter, you can see the probability that I get exactly 12 is listed right here. 0.05257. Let's round this 4 decimal places, so 0.0526. So the probability of getting exactly 12 tails is 0.0526. Think that I rounded that right. Let me double check. 0.0526. Good. All right, the last thing we're going to take a look at is, in a binomial situation, finding the mean and standard deviation. So to find the mean, we have a formula. It's on your formula sheet. It's n times p. Well, look, we know what n is, right? And we know what p is. So to find the mean, it is going to be 0.5 times 32. And I think 0.5 times 32, that is 16. Now, think about this in terms of what we're saying. If you flip a coin, on average, you can expect about half of them, or 16 out of the 32, to be tails. So that's what we mean by a mean. It's just kind of like the average, what you can expect to get. Now, standard deviation is a little bit different. It is n times p times q. And we haven't really defined what q is equal to. So q is just the complement of p. Or another way to say this is q is equal to 1 minus p. Now in our situation, q is equal to, well, 1 minus 0.5, which is also 0.5. So we know, so to calculate our standard deviation, it's going to be the square root of n is 32 times p is 0.5 times q is 0.5. So let's get our calculator out. It's going to be square root of 32 times 0.5 times 0.5. Make sure you're using your time sign and not closing parentheses when you do your square root. And when I do this, I get 2.8284. All right, so the standard deviation for this one is 2.8284. Again, we'll go into a lot more detail with this in class, but this is just a basic idea of what we're going to be doing in week 7.